Welcome to this presentation on developing C programs on Linux with Visual Studio Code. Visual Studio Code is an open source programming editor from Microsoft that has a really excellent tooling for doing C development on Linux. And in this presentation I'm going to show you how to configure Visual Studio Code to develop a C program that has a couple of source code files in it. I'll show you some of the editing and navigating features, and then how to run and debug. I'm going to assume that you've already installed Visual Studio Code on your Linux system. It's not difficult to do, but I do want to demonstrate how to install the C and C++ extension. So I'm going to go ahead and start Visual Studio Code just by typing code from a shell prompt, launches it. And we're going to come to the Extensions tab over here on the left, and I'm going to search. Actually, C and C++ is listed down here. If it wasn't, we could just search for it and find it. You want the one from Microsoft, and I'm going to click Install. And when the install completes, the extension is enabled and we're ready to go. So I'm going to go ahead and close this tab and click back over in the Explorer. Now, I launched Visual Studio Code from a directory where I already had a C program located. But I want to make this point that it's important that if you launch Visual Studio Code and you're looking at just a new window, something like this, for example, that you use, in order to open your C++ code, you want to use the file open folder, not open file, but open folder, and you want to navigate to the folder that contains your C program. That will ensure that Visual Studio Code launches the compile tools in the right place and that things work smoothly. So now that we have the extension installed, I want to show you some of the editing features that are available in Visual Studio Code. So I'm going to click on main.c here, which has a couple of functions in it, and the first thing I want to show you is this outline view, which you can click on down here. This allows you to see the functions that are defined, and you can click on them to jump, put the cursor directly on that spot. IntelliSense and code completion is available. For example, if we want to call the puts function, because we have pound included standard.io.h, we have this information available to the editor, and it shows you hints about what the parameters are and so forth. You can comment and uncomment blocks of code, so I can select several lines of code, and you can press Control/. I'm holding down the Control key and pressing slash to comment that, and I'm pressing Control/ to uncomment it. It's very useful. I want to show you how to write certain common C statements. Let's say you want to write a for loop. So you start typing for, and up here at the top is this first option. If you click on it, this will insert a template of a for loop with a suggested set of variables to use, and you can edit that and make changes to it. So all the common C statements are available like that. Intelligent renaming. If you want to rename a variable, you can right click on it and choose rename symbol, or just press F2. And let's say I want to call this sum instead of result. So I'm going to type sum and press enter, and we have a pending rename going on over here, and I'm going to check the commit rename option, and that renamed those variables to some. Finally, I wanted to show you about reformatting code. Let's say that you're kind of careless about the white space that you use. Maybe some things aren't indented just right. You can right-click the document and choose Format Document, or press Control-Shift-I, and that fixes the indentation all up beautifully. There are ways that you can configure the way the indentation works, but the default looks pretty good in my book. Let me show you some code navigation features. The first one is my favorite. You can use Control-Click on a function call or variable to jump to the place where it's defined. So I'm holding down the Control key, and then when you move the mouse around, it turns these functions into hyperlinks, and it shows you the definition of the function, and if you click on it, it jumps the cursor to the place where the function is defined. I'm holding Control down and I'm going to click on Add, and it'll even navigate it in another file. That's very useful. The breadcrumbs are another useful feature. Up here at the top, these breadcrumbs are clickable. If you click on this top function here, it drops down a list of all the functions in this file. This is similar to the outline view, but you don't have to have the outline view open to use this. And then Control-T can be used to navigate to a function defined anywhere in your project. So I'm pressing Control-T, and up here at the top I want to navigate to the sum function. So I'm typing the add function, and it shows me that there is a declaration for add in util.h, and there is a definition for add here, so you can jump to either one of them. If you wanted to go to the declaration, you could click here and jump to the header file. So Control-T, which is also on the Go menu, if you can't remember, Go to Symbol and Workspace is what I just demonstrated. Navigating to function declarations. So let's say we're at the add function and I want to get to the place where it's defined in util.h. I can right click on add and choose go to declaration, and that will take me to the header file that defines that. They've really done excellent work on this code navigation stuff. The last thing I want to show you is that if you're in a project that has lots of files and you want to easily navigate around, maybe you've got subdirectories and so forth, Control-P is very useful. Let's say I want to get to, I'm pressing Control-P here, and here's a list of all the files. If I want to go to main, the file name main.c, I can just type part of the file name and click on it to jump right there. So those are some of the code navigation features. Now I want to demonstrate compiling, running, and debugging your code. The first step in the process is to set up what Visual Studio calls a debug configuration. There are a couple of ways to do this, but I think maybe the easiest way is to use the Start Debugging command on the debug menu to generate an initial configuration and then customize it as needed. So I'm going to do that here. I'm going to open the debug menu and choose Start Debugging, and Visual Studio Code prompts us what kind of language we're working with. So I'm going to pick C++, which is what you want to pick for either C or C++. And then this second list, this determines the default configuration options that are used. If you're using GCC version 7, you could pick the first one. I'm just going to pick the second one, which works for any version of GCC. This does a couple of things. This generates a launch JSON file and fills it out with a default configuration here. In this file, you're going to want to, if your project contains more than one C source code file, you're going to want to specify the name of the executable. And in our case, our make file, I'm going to go ahead and show you the make file that I created for this project. The make file just builds all the C source code files and links them together into an executable named prog. So in my launch.json file, I'm going to indicate that the executable name is prog. And to make sure that this works, even if we have subdirectories involved, I'm going to go ahead and change this first little variable to workspace folder. So what this means is that when we start the debugger, it will look for an executable named prog located in the root of our workspace folder. Now, the second thing we need to do here is create a launch task. And sometimes this is created automatically for us. It wasn't in this case. This pre-launch task option down here is referencing a launch task named gcc build active file. That didn't get created for us automatically. So I'm going to copy this. And then I'm going to hop over here to main.c and choose terminal configure default build task. And I'm going to pick CC++ GCC build active file. That creates a new file called tasks.json with a configuration that will use the GCC compiler to build whatever file is the current file in the editor. And we're going to tweak this a little bit here. I'm going to use the make command instead of GCC because our project has more than one file in it, and I have a make file. So the make command is going to run, and make doesn't take any command line arguments. This args array is used to provide command line arguments to the GCC compiler, but make isn't going to need those, so I'm going to delete those. And then I'm also going to delete the current working, well, actually I want to set the current working directory here to our workspace folder, so that when the make command runs, it's running in the root of our workspace folder. Now with those changes, I can close tasks.json and launch.json. Those files are over here if we need to edit them again. And by the way, if something gets messed up in those files, you can always just delete them entirely and go through this process again to set them up. Now that we have set up our debug and build configuration, we can use these two commands to compile and debug. If we just want to compile, we can choose terminal run build task. So I'm going to do that. That's the Control-Shift-B option right here. And that executes the make command. You can see the GCC command from the make file that got executed. And then there's this notice that says you can press any key to close this terminal window. And then to start the debugger, I'm going to set a breakpoint out here to the left of main and choose debug start debugging, F5. That runs make again and then starts a debug session, and the breakpoint has been hit. We're looking at the debug console right here, and we can start stepping through with the commands that are on our debug toolbar. For example, we can execute this print greeting line with the step over command. Your output is going into the terminal part down here, so you can see the output over there. The debug console is used if you want to look at the values of variables. Some variables are displayed over here on the left, but if you want to look at a global variable, you can just type the variable down here and press enter. You can type any expression you want to. Really, for example, we can call the print greeting function and pass in a string, and that executes, and the output goes over here in the terminal. So this is a useful runtime expression evaluator prompt. What if we have compile errors? I'm going to go ahead and stop the debugger. There's more to be said about the debugging features, and I have a whole separate video that's available that gives you information on some of the additional debugging features. I'm going to go ahead and stop the debugger, and let's introduce a compile error. So I'm going to backspace over this semicolon and save, and as soon as I save, the editor is indicating with red squiggles there are problems. And we also have the problems mentioned over here on the Problems tab. If we try to run at this point by choosing Debug Start Debugging, there will be an error that indicates that there are errors that existed after that build, and usually when you get this dialog, you're going to want to click Show Errors instead of Debug Anyway. If you choose Debug Anyway, you're just going to be running debugging the last successful build of your application. Well, that concludes this very brief presentation on using Visual Studio Code. I think Microsoft has done an absolutely fabulous job at creating C and C++ features for development in Visual Studio Code. And if you want more information, just check out their website. Thank you for watching.